Hello grade 10s, welcome to my channel. I'm new to YouTube and I am dedicating this channel just to help people who pursue mathematics for grades 10 to 12. Now, I know how most of you must feel now that you are in grade 10. Stressed, you don't know what to expect. Well, I'm going to be honest with you. Mathematics in grade 10 is a huge step from grade 9. I mean, you're doing a whole bunch of new stuff. You are doing functions, you're doing analytical geometry, you are doing more complex patterns, and you are starting with trigonometry this year, but rest assured, I will guide you through it. By the grace of God, it's not that hard. Okay, so let's quickly revise exponential laws that we did last year. Okay, so whenever we have something like this, and it says x to the power of m times x to the power of n, well, now you must be sure that both are x's. Like we will see here in number 4, there's an x and a y. I'll show you what to do there. But when both are x's, all that you're going to do is, and you're multiplying, you're not adding or subtracting, you're multiplying, then you're going to add these two together. So then it's just going to be x, because it's two of the same, x m plus n. Okay, x to the power of m divided by x to the power of n. Now it can also be written like this: x to the power of m divided by x to the power of n. You did this in grade 8 and 9. It's old news, you guys know what to do. You're only going to subtract the m and the n from each other. Here, what I want you to do is, when there's a bracket dividing the two exponents, you're going to multiply those two with each other. So it's going to be x m times n. Not plus, that was if we are only going to multiply the two terms. But here it's a bracket and the whole thing is to the power of n. So then you're going to multiply those two exponents. Now, when we do not have the same variable, like here we have an x to the power of m and a y to the power of m. An x and a y is not the same thing, so we cannot add them together. But what we're gonna do is, we can say both of our exponents are the same. So what can we do? We can say x times y, we're gonna multiply them, put them in brackets to the power of m. Okay, so when we do not have like terms but our exponents are the same, we're going to put it in a bracket, times it with each other to the power of m, just to simplify it. Okay, these last two, learners always struggle with. When something is to the power of a negative, when your exponent is negative, it's a fraction. So actually what is written here is 1 divided by x n. Okay, let's put it in a more way that you guys may know. Like if there is 2 to the power of negative 1, it's actually, take the 1, it's 1 divided by 2. Or 4 to the power of negative 1, it's actually 1 divided by 4. Okay, and when we simplify exponents, we never want to leave our answer like this. We always want to leave our answer like this. Otherwise, they're going to subtract marks. Alright, and the most important thing, anything to the power of 0 is 1. It could be 3 to the power of 0. Check, I'm not lying. 3 to the power of 0, it's 1. It could be 1,000,000 to the power of 0, it's going to be 1. Let's type million to the power of 0, it's 1. Okay, so anything to the power of 0 is 1. Okay, let's look at our first example. They're asking us to simplify this. Now, start by referring back to your exponent laws. We see a 3 and a 5, it's not the same thing. They already put it in brackets for us, and the bracket has an exponent. Okay, so refer back to number 4. We're going to say this exponent goes along with that one. So it's 3 to the power of 3. Keep it in brackets, you don't have to. Times 5 to the power of 2. There's a bracket and another exponent. It's this one. Then you just multiply these two. So it's 5 to the power of 2 times 3 is 6. Minus 75. And when you pop that into a calculator, you would get an answer of 421800. Okay, let's look at this one. When you just look at this stuff, sometimes it looks like you're trying to read the Greek Bible or something, but it's not that bad. Just remember and refer back. What is this? What times what gives you 9? 9 can be put under a square root. It's 3. Okay. So this is a polynomial. Polynomial. So it's going to be 3x, 2 brackets. Both has a 3x in because 3 times 3 gives you 9. The exponents are the same. Okay. We have a minus. A minus means we have a minus and a plus. And we just write the 1 down because why? When we square root 1, it's going to give us 1. If there stood something like 36, we would say the square root of 36 is 6. So we would write a 6 and a 6 there. If it was 49, that stood there, it's going to be a 7. So we write 7, 7. Okay. That's above there. And now we're dividing by 3 to the power of x plus 1. These two are the same, so they cancel out, leaving us with the final answer, which is 3 to the power of x, take away 1. Okay, in this one, they're asking us to solve for x. Now, when we have, like here we have 2 to the power of x. When we have something like this, we always want this side also to be a 2. It must be the same as the one the x is a power of. So, now your question is, how do we turn this into 2? Well, maybe we can say 2 to the power of negative 2. That's 4. No, it's 0.25. It wouldn't work. 3. There we go. It's 0.125. So 2 to the power of x is the same as 2 to the power of negative 3. We have the same, both are 2, so they cancel out. So that means that x is equals to negative 3. And of course, if we would just pop it back in, I mean it's obvious, you would get the answer. Okay, not hard. Next one. 2x to the power of 3 divided by 2 is 54. Now, when you guys see this, you panic. Just remember, we want our x's alone, so we're going to divide by whatever is in front of the x. We're going to divide by 2, and what we do on this side, we have to do on this side. Golden rule of mathematics. That leaves us with x 3 divided by 2 is equals to, now I'm sure you guys don't have to do this, but if you struggle sometimes to do basic math, Take your calculator. That's why you have it. Now 54 divided by 2 gives you 27. There we go. Okay. Now all that you can do is, here you guys don't know what to do. Let's say we have an x to the power of 2. Okay. How do we get rid of this? Remember Pythagoras. We're going to put it in the square root of 2. When we would have had something like x to the power of 3, we're going to put a square root to the power of 3 because then those two cancel out. So now we have x to the power of 3 divided by 2. So we're going to put it in a square root of 3 divided by 2. What we do on the one side, we have to do on the other side. So it's also going to be 3 divided by 2. Those two cancel out. Take your calculator. If you guys don't know what I did there, I said shift square root. Then it gives you that. Then you can just press this button, delete, and you can change it as you like. 3 divided by 2. And it's 27. So x is equals to 9. Now we can of course check if it's true. So let's say 2, we just said x is equals to 9 to the power of 3 divided by 2. There we go. It gives you 54, so you know your answer is correct. Okay, this one I put a star next to, so we're going to do it later. Let's just go on with these. Okay, this one is a bit tough. So first, I want to get your attention to this. Remember how I said 1 divided by x is the same as x to the power of negative 1. So we can rewrite this as 9 to the power of negative 10. Because it's just the same as we would have done 2 to the power of x is the same as x to the power of negative 2. It's exactly the same. So we can say it's 9 to the power of negative 10. Write the bottom one first, like here, and then the top one becomes your exponent. Okay, just like we did here. And then it's 3x plus 1 plus 3x minus 1. And you know what? We can change this 9 into a 3. How are we going to do that? We can just simply say, what is 9? 9 in terms of 3 is 3 to the power of 2, negative 10. Look at this, number 4 of our exponent laws. So this is actually the same as 3 negative 20 because we multiply those two with each other. 3x plus 1 plus 3x minus 1. We have 3's all along, so we can cancel them out. Okay, now we're left with x plus 1 plus x minus 1 is equals to negative 20. We take these over the equal to sign because they are not x's. We want x's on the one side and all the others on the other side. So this is just going to cancel out at this side because this becomes positive, so it's going to be negative 19, and then this one becomes negative again, so it's going to be negative 20 again. So then we're left with 2x, because x plus x is not x squared. We're adding stuff, so we have 1x, we're adding another x, so it's 2x's, is equals to negative 20. Dividing by 2, dividing by 2. So it means that x is equals to negative 10. Okay, now let's look at this one. X to the power of a half plus 3x to the power of a quarter minus 18 is equals to 0. Now, this, we see we have an x here and we have an x here. Do you guys remember the k rule from grade 9? We can say let k be equals to x to the power over 4. Now you're going to ask me why x to the, to a quarter. Why this one? Because a half can be rewritten into a quarter. A half is twice as much as a quarter. So we can say what here, as when we say x to the power of a quarter is k. So then here it's going to be k to the power of 2, k squared, plus 3k minus 18 is 0. And now it's just a normal trinomial that you have to factorize. So let's go. Let's say 18 is equals to shift fact. Where is my fact? Shift fact. There it is. Okay. It's 2 times 3 to the power of 2. Now we can rewrite this as 1 times 18, 2 times 9, 3 times 6. And we can't go further. Now, what can we subtract from each other to give us 3? Why subtract? Because there's a minus. If there wasn't plus, then we would say, what can we add together to give us that answer? But now it's minus, so we're going to say, what can we subtract from each other to give us that? A 6 and a 3, because 6 minus 3 gives us 3. So we're going to have two brackets, a k here and a k here. K times k gives us k squared. We said it's going to be 6 and 3. When we have a negative here, it means our signs are not the same, meaning we're going to have a negative and a positive. But now we refer back to the first sign. It wasn't positive. That means the biggest bracket is going to get a positive. If that was a negative, if that was negative 3k, then there would be a negative in front of the 6. Okay. And then the other one is a minus. So that means that k is equals to negative 6 or k is equals to 3. But did they ask solve for k? No, they said solve for x. And remember, k is equals to x to the power of 4. So actually, it's x to the power of a quarter is equals to negative 6. Yes. X to the power of a quarter is equals to 3. Divide both sides with a quarter, like so, to get rid of this one. It's gone. Thus meaning x is equals, pop it into your calculator. Remember, don't say negative 6 in your calculator, because then it's going to say math error. Okay. So just for now, say 6. So it's shift, we change that to a quarter, and it's going to be 6. So that's our answer. But remember, it was a negative 6. So just remember to write your negative there. Alright. Or our x is equals to, it was a quarter of 3, and that is 81. Okay, now we're back to the star one. We're dividing with exponents here. Okay, so remember, when we're dividing with exponents, we're looking for like terms, for x's that are the same and y's that are the same. Alright, so we can all agree that a 10 and a 5 are both numbers. They are not x's and y's and z's. So 10 divided by 5 is what? It's 2, right? 2. Now what do we have here? We have 2 x's here, and we have 1 x under. So where's our x's gonna go? Where do we have more x's? Here. 1 x is gonna cancel, and it's going to take that one. So 1x remains. We have 6y's under the line, and we have 8y's above the line. This 8 can take these 6y's, and there would still be 2y's left. So that is our answer. Okay, next one. Negative 20x cubed y to the power of 4 divided by 5x squared. Now, a negative 20 and a 5 are the same. They're both numbers. So negative 20 divided by 5 is negative 4. Okay. If you don't believe me, take your calculator, say negative 20 divided by 5, it's negative 4. We have 3 x's here, we have 2 x's here. If you want, you can do as you did in grade 8. You can rewrite this x as x times x times x times y times y times y times y divided by x times x. Okay. We can take a x there, take a x there, take a x there, take a x there. There remains one x above the line, so there's going to be x there. And the y has nothing to subtract itself with, so the y to the power of 4 is just going to remain the same. Or you can do, you can say there's more x's above the line than under the line, so those 3 can eat the 2 up, okay, and nothing remains here. So then it would be like this. Okay, now we are multiplying. Remember, when we're multiplying, we're looking for the same terms. Okay, just as the as we did with the previous one. Okay, 4 times 2 are the same. 4 and 2 are the same. They're numbers. 4 times 2 is 8. X squared times an x. Above that x is actually x to the power of 1, right? Anything to the power of 1, it is itself. So when we multiply with exponents, what do? We're going to add those two. So it's going to be x to the power of 3. We have a y to the power of 8 times a y to the power of 4. They are the same, and we're going to add those two. So it's going to be y to the power of 10. Okay, this one. Now you have to be very careful because they catch you guys with these. We are not multiplying and we're not dividing. We are adding now. So we cannot use these and say we're going to add the exponents to each other. No, because we're not multiplying. Now we have to look for like terms as a whole. So we see we have an x squared y3 here. Here is x3 y2. It's not the same as these, because an x squared and an x to the power of 3 is not the same thing. But here we have an x squared and a y to the power of 3. These two are the same. And here we have a 3 to the power of 3 and a y squared. These two are the same. So we're going to add like terms. It's going to be 4 times 1 is going to be 5x squared y3 plus 2 plus 3 is 5x to the power of 3 y to the power of 2. We cannot add those because it's not like terms. Say this was just x and this was y. Then we can't add 5x plus 5y because the x and y are not the same thing. Okay. Alright, the last one. Now we're not multiplying, we're not dividing, so we can't use these exponent laws. We have to look for like terms. Remember that, please, especially when you guys are going to do in grade 10 you would be doing solve for x and y simultaneously. It's extremely important to remember to look for like terms. Now we have an y squared x here, and here we have a y and an x squared. These two are not the same, but here we have a y squared and an x. This is the same as the 6, so these two are the same, and we only have one lonesome 4yx squared. So we're gonna add like terms. 6 take away 2 is 4y squared x minus 4yx squared. Can do nothing else because these two aren't the same. I hope you guys enjoyed this video. I hope you are more relaxed concerning exponents. And yes, my email is in the link of the description of the channel. You guys can email me personally if you have suggestions. Thank you guys.